Hey GED students, I want to take a look at this table here and some of my weird wording. And what I really want to stress here as we think about perfect squares and their roots is two things. One, patterns. Patterns are so important to math. A lot of GED students think, oh, I got to memorize all this information. If you can notice patterns, you have to memorize a lot less info. A second thing here is the idea of opposites. Once again, if you can move forwards in something, then you know how to move backwards. And we've cut in half, again, the number of things we need to memorize if we can see that. So let's go ahead and take a look here. Directions say, complete the table. Oh, we need a pen here. Okay. Directions say, complete the table by filling in the empty cells with the appropriate equivalent expression. So right away, I'm throwing some words at students that makes them freak out a little bit. But guys, nothing challenging to this language. Equivalent means equal. And an expression in math is just a really simple way of saying a math phrase. An expression can be as simple as a number, like 7 or 33 or 100, and it can be more complex. It can involve operations. It can involve letters. But here we can see what kind of expressions we have. We have exponential expressions, in particular square roots. We're looking at square roots. So in this case, our expressions are just square roots of a number, or else the simplified answer, the number itself. So let's go ahead and fill this sucker in. So first one, we see this exponential expression, this square root of 0. And I want to go ahead and I want to simplify this. So what is the square root of 0? Well, what I'm asking when I ask the square root of a number is I'm saying, what number? I'm going backwards from squaring. What number squared would equal 0? Well, that one's simple. Of course, what number squared would equal 0 is 0. 0 times 0 is 0. And the next one is equally as simple. If I ask you the square root of 1, I'm asking you what number squared is equal to 1. And once again, that one's pretty simple because we know that 1 squared, or 1 times 1, is 1. But from here, we're getting a little more complicated. And I was kind of a jerk. Look how I am. I made you work backwards. I'm asking what square root expression here is equal to 2. And that's an interesting way of looking at it backwards. But it's kind of should lean right from what we learned about those perfect squares. Because we know what the square of 2 is. It's 4. Because we know what the square of 2 is, it's 4. We know what number squared will give us 4. And that's 2. Interesting. Okay, so the square root of 4 is 2. And you're going to notice a really interesting pattern here, which is why I didn't just leave the right-hand side for you, because we can see the next one, the square root of 9. I'm asking what number squared? What number squared is equal to 9? And of course, that's 3, right? 3 times 3 is 9. Another way I'll read these square roots, if the what number squared language is confusing you, you can say what number times itself. And that sometimes helps students more, since square is such a new concept. But we've been timesing or multiplying for a long time. So what number times itself? So what number times itself is 9? Of course, it's 3. Now I have another one moving backwards, and I'd like you to put in a square root expression here. So, what number would I have to square root to get 4? Well, again, think of it the opposite way. 4 squared is what? It's 16. So if 4 squared is 16, we can move backwards and say then that the square root, the root of 16, what 16 is made of when you square it, is 4s. Wonderful. So then the square root of 25, what number times itself is 25? Well, of course it's 5. And now I'm making you fill in the square roots again, because I didn't want you to just write down the right-hand side, 0, 1, 2, 3, 4, 5, 6, 7. Okay, you guys. So what square root expression here would give me 6? Why, of course, it would be 36. The square root of 36 is 6 because I can flip that around on its head. 6 squared gives me 36. All right, so same thing here. What square root would give me 7? Well, it'd be the square root of 49 because 7 times itself is 49. Looking back down, oh, this one's easy, right? 6, 7, 8, 9. But how come? Because the square root of 64 is 8. What number times itself equals 64? 8. So what square root here would equal 9? Well, it'd be the square root of 81. The square root of 81 is 9 because 9 times 9, or 9 times itself, would give me 81. What could I fill in here? Well, the square root of 100. Because 10 squared is 100. That means the square root of 100 is 10. I can flip that on its head because I understand inverses. And similarly, this one would be the square root of 121. That would be equivalent to 11. And the square root of 144 would be equal or equivalent to 12. All right, good little review of the square roots of our perfect squares. Again, this is one of those things I like you to have memorized, guys. I do like you to have memorized perfect squares and square roots, but here's the deal. There's only so much you guys are going to memorize. There's only so much you're going to remember. And depending on your particular bent, your learning styles, just the way you study, you may remember more or less things. Perfect squares are one of those things I love for you to have memorized because of this, because of what we just did. By memorizing the perfect squares, we also have memorized our square roots. You know, it's like two birds with one stone. It's double our money. But as we've just seen, you can create this every time. You don't have to have it memorized, but it is useful and it does make this process a lot quicker. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.